Thank you for giving us the opportunity to speak here today. It's been a very interesting morning. What I'll be presenting today is a couple of examples about how you can use optimization to make better decisions, and basically in the face of uncertainty, especially uncertainty on the demand for your product or service. But before I do that, I just want to say a few words about what the Smith Institute is. We are a consultancy company based in Howell, out in Oxfordshire. We are a group of mathematicians and statisticians who use mathematics, statistics, data science, and advanced analytics to solve problems for businesses and governments. Some of our clients are on this page, among all my colleagues. So we work in fast-moving consumer goods, in energy, telecommunications, and security. The place that I want to start is an example that where we worked with a lettuce producer. So imagine that you have this farm, you're producing lettuce, and you have a pretty good idea about what the demand will be for lettuces throughout the year, because you've been producing lettuces for a long time. So you have historical data, and you get you get knowledge about that. Of course, there's uncertainty in that demand. Especially, it's important to know when the first barbecue weekend will be, because consumption of lettuce go up in that weekend. The question that you're forced to answer is, when do I need to plant and sow my lettuces in order for them to be ripe and have the right quality on that weekend, and indeed to serve the demand throughout the season? Everything becomes a bit more tricky when you start thinking about the fact that you're producing a product that only has a very limited shelf life. So the window in which you have to plant everything in is quite short, and the growth of the thing that you are producing depends on the weather as well, which is also uncertain. So the question that you want to ask, well, when should I plant to be ready for a specific day during the season? And how much should I then harvest on that day as well to make sure that I have enough for the rest of the season? And also, I may have several fields. So what type of products should I plant in every single field? Some fields might be better for producing lettuces than others because they are situated in different locations. Maybe some are in the shade of some trees or whatever. So there's a lot of these constraints that will shape the solution that you get, the planning of the planting and the harvest. Now, given that all of these, so the demand itself, the production, so the growth season, and will depend on the weather, there's a lot of uncertainty around it. So being able to run through different scenarios, and in every scenario get an optimal planting and harvesting plan, is a very valuable tool in order to make the right decisions about when to do those tasks. So this is sort of the planning question. And in operations, it could be, for example, to set the prices of the product that you're trying to sell. Now, all of this can be done using optimization, so putting it all together in an optimization product. Another example could be a coffee shop. In a coffee shop, you have, again, from historical data, you might be able to determine what the demand for coffee will be during the day. How many customers do you have in each maybe 10-minute period during the day? Now that demand will change from day to day, depending on the day of the week, the time of the year. is there special events going on? But what you want to do is you want to make sure that you can serve that demand in the best way, but do it as cost efficiently as possible. So you need to ask yourself, well, how many baristas do I need to serve my customers, so that we don't have too many queues and and customers tend to leave if the queue is too long. Because after all, having the number of people that you have on staff is probably going to be the highest issue for reducing the cost, if you can reduce that number. Now, the demand profile for coffee might be have several different peaks. So during the day, so that you have a morning peak when people come for coffee, and then also maybe an afternoon peak. So maybe you can try and explore whether what type of contracts you want to give to your employees. Do I really need all of my employees to have full-time contracts? Or would it be better to have some that are only working part-time, and where should I then use them? All of that, again, is a planning question that you can answer with optimization. So again, playing out different scenarios where you can explore, well, what does that do to my cost? Again, at the end, at the operational scale, it's about, well, now I know how many employees that I have. I know their requirements in terms of or the preferences in terms of work. When would they prefer to work? There are work requirements around, not if you close the shop, then you can't open it again. All of that you can combine into a optimization model and then produce your operational schedule for when staff should be at work. Now, of course, this is just two examples of a very, very general thing. One from a production environment, another from the service sector. Common to both of them is that you have some kind of demand. You have a forecast of your demand, wherever that comes from. And you want to make decisions about how to meet that demand. And that's where your optimization comes into the picture. So you have your demand forecast, and then you have an optimization model that can be built around that to serve that demand in the most efficient way. So again, it's the question is the first example is, when should I sow and plant my lettuce in order to meet the demand and reduce the cost? And the other one, it's about how much staff is needed at a given time to keep service at a high quality, but also minimize the cost at the same time. When you, in general, when you embark on implementing a new analytics solution, you have to, you have to have a quite good understanding of what is the business problem that I want to solve. And then, when you have that, you need to consider, well, what quantities do I have? Which of these quantities can I change? Which have I control over, and which can't I change? And when you know that, so the quantities that you can change, that's where your decisions come into the picture. Then there's the question of, well, what constraints do I need to put on these quantities? Are there limits to what I can do? And how do these quantities all fit together? And what are the costs of making different decisions? What data do I have to support this? Do we have a demand forecast? Do I have business general business data? And I need to decide on a range of metrics that I can evaluate my my decisions against. And then you also need to decide on, well, how am I going to use the solution? If it's in a planning solution, you might want an optimal solution because you have a sufficient time to find one. But if it's an operational solution, then you might just be happy with just getting an answer or a good answer. And your horizon, the time you have available to you, highly depends on which you choose. So, for example, in the planning of lettuces, some of the quantities that we can control are the sown and the harvested. The constraints we have is how much work can we actually do in a given day. There's constraints around how quickly things grow, what the capacity of the field is. In that case, we probably want an optimal solution because we have time to explore it. And some of the metrics that we can use is, again, the gross margin, it's the quality of the products that we're delivering. Some of the data that we have is the weather data and the demand that we're forecasting and other types of business data. A different example here again is the staff rostering. The quantities that you have is the staff availability, the shift that you want to cover, the work that needs to be done. Some of the constraints are work shift constraints. You may only have to be able to do one shift a day, what type of contracts you have. Metrics in this case, again, gross margin could be a thing. So, but also employee satisfaction. You might want to produce staff rosters where your staff have a similar schedule every single day because that will keep them more happy. But it's more than sort of an analytic solution is more than just the tool and the mathematical model that sits around it. Often you will need to, in order to build the model, you need to engage with the wider business in terms of understanding how the business works, what the actual problem, how that problem fits into other parts of the business. There's some data engineering to prepare the data, create the demand forecast maybe. And often you've come and wanted to do a more advanced solution because you already have something. I mean, a spreadsheet implementation is the classical thing. So there's some kind of change management you have to do within the business itself to capture that. So it's more than just the mathematics of it. That's why we often take a sort of a phased approach when we do this. So you have to learn how to walk before you can run, and you have to be able to crawl before you can walk. So you define your problem in the crawling stage. You figure out what data that you need to collect, and in the middle step, it's about building the prototype, and very importantly, it's about building a baseline, determining how good your prototype solution is, and then creating a roadmap for how you want to implement it. Now it looks like this is a sort of streamlined process from the left to the right, but in actual fact, it's more of an iteration that's going on. So it's more complicated than it seems, as everything is. But finally, I want to conclude with saying that using optimization solutions, you can get something that's tailor-made for your specific use case. Capture the requirements of your specific business problem. By playing out different scenarios and looking at what are the optimal decisions in every case, you can get a visibility of the impact that uncertainties they can have on your sales and your growth margin. And using this type of decision making and this aid to decision making can reduce the cost of your operation, and doing that without sacrificing the quality of your product, and thereby setting yourself ahead of the competition. Thank you for your attention.